Seeking English, S.A.T. Workbook, page 388, problem 2. You may use a calculator for this, and I expect that you will use a calculator for this. It says the elevation of a mountain peak in meters is approximately 20% less than that of a nearby peak. The elevation of the nearby peak is 6,195 meters. Which of the following is the best approximation of the elevation in meters of the unknown mountain peak? Choices: 4,865 meters, 4,950 meters, 5,000 meters, 5,155 meters. Okay, there's a mistake that people very frequently make in this kind of problem. It seems like they are slightly less likely to make it if they conceptualize the heights of the mountain as being money. So I'm going to go back to my tax and discount discussion, which you may have seen in a previous video. It's worth reiterating. Okay. I use the tax and discount terminology because it makes people brighten up a little bit. It makes people sharpen up a little bit when you convert what you're talking about into money. Since the whole test is basically a collection of metaphors anyway, changing your metaphor momentarily to make the problem more interesting to you is not unreasonable. Most people have not calculated the heights of mountains. Most people have received a tax and have paid a discount, and it has mattered to them because people seem to care about money. A tax multiplier is a multiplier which is larger than 1, and a discount multiplier is a multiplier that is smaller than 1. A tax multiplier will take a positive number and make it larger. A discount multiplier will take a positive number and make it smaller. Okay? You get your tax multiplier by taking 1 and adding the tax to it. Excuse me. You get your discount multiplier by taking 1 and subtracting the discount from it. Now this is where many people go wrong again and again and again and again. They conceptualize discount as a subtraction or as a division. That's the wrong way to conceive of a discount. Regardless of how it's described to you when you're actually doing the math, you should conceive of discount as a multiplication of the thing by a number smaller than 1, and that will make it smaller, despite the fact that you're multiplying it. Okay, so in this story, it's going to be meters, not dollars, but the math is the same. The elevation of a mountain peak in meters is approximately 20% less than that of a nearby peak. This is another place where people go very, very wrong. The 20% is part of the larger mountain. It is not part of the smaller mountain. Adding 20% to the height of the smaller mountain is not going to give you the height of the larger mountain. If you take one of the numbers that's on the list in the book, multiply it by 120%, then you get the larger number. No, that's wrong. 20% of the larger number is not 20% of the smaller number. Stop the video if you don't understand this. Back it up. Listen very carefully to what I'm telling you, because this is an extremely common problem that if it sounds like it shouldn't happen, it does. Happens. I see it almost every day. 20% of the larger number is not 20% of the smaller number. What you want to do is you want to take the known, which is the larger number, okay, reduce it by 20% and get the smaller number from there. You don't want to take these numbers and multiply them up to see if they fit the larger number. That's not how it works. Okay, so what are we going to do? We're going to discount our mountain. That sounds weird, but that's what the math allows us to do. Okay, we're going to take the size of the mountain, which is 1 mountain, and we are going to subtract. Okay, we're going to subtract 20% from that, 0.20. Okay, so our multiplier is going to be 0.80. It's going to be 80% of the size of the larger mountain. And this problem says that the larger mountain is 6,195. 6,195 meters times 0.80 or 0.8. And this is where I would suggest use a calculator, just because it's going to be faster for most people. You know, pop up my calculator here. 6195 And what you can't see is that I'm not even bothering to do the decimal on this. I'm just putting in 8. Why? Look at your answers. How different are they from each other? Not very. So times 8. I got 49560. Decimal positions do not matter. Okay. We have 4865, 4950, 5000, and 5155 are your choices. You can write these down and compare them. I'm not going to put them on the screen. 4950 appears to be the correct answer. Okay, now this is a point where I can bring up the distinction between accuracy and precision. Aren't those words, don't they mean the same thing? Well, they don't mean exactly the same thing. They are used interchangeably, but in fact they do not mean the same thing. The answer 4865 appears to be more precise. It looks like the other answers are possibly rounded. But you're going to have to round. You're going to have to round that number. What is it? Yeah, that 4956. You're going to round the 6 down. Really? Yes. Why? Because it is still closer. 4956 is closer to 4950 than it is to 4865. Do not let that 5 or the other 5. Don't let either, but especially not that first 5. Don't let this apparent higher degree of precision fool you into thinking that the answer is more accurate. Now, what I've said is really weird. I know, but give it a chance to sink in and watch the video again if you have to. Think about what I've said here because it does make a difference in terms of how you select your answers on the test. Precision and accuracy are not the same. Sometimes rounding down is the less inaccurate answer.